Hi, everybody. I'm going to do a short video on function generator that we're going to use in the lab next experiments. That's the function generator. The first thing we should know, the power button. That's the power button to the left. If you push it in, then the bar comes on. The first row that you can see here is the frequency range. Start from 1 hertz, 10 hertz, 100, 1 kilo, 10 kilo, 100 kilo, 1 mega. That's the range. You see here the green light, it means I pushed already 1 kilo range. And then if you want to change the frequency, you can change it by turning the knob anti-clockwise direction to get the minimum value, and you turn it to clockwise direction if you want to increase the value of the frequency. And the frequency that you read it here on the screen, it's the real value, the actual value. You don't have to multiply it by any factor here. Okay, so for example, what you have here, 3.2657 kilohertz, that's the value of the frequency. And the second row, I'm going to focus on the second, third, fourth button. You can choose the wave signal according to whatever you need. For example, the first one is sinusoidal, and the second one is triangular wave, and the third one square wave. And these are the signal we're going to use through the semester. I'm going to show you the whole thing here. That's, the sinusoidal signal, that the first one, and the second one, square wave, the third one, triangular wave. The last one, sawtooth, we're not going to use it now. Now, we go to the this row, the last one, as you see, the one to the right here, that's where you put this cable, and to do the cable, you have to, and now I'm going to screw it, I'm just turning to clockwise direction, and I'm pulling, this one. That's the kind of cable, that's the end of the cable we're going to use. So, to put it in, look, here you'll find like some kind of groove here, and then you go and match it with the thing here, and you push it in, and then you twist it to make sure it's not slip when you pull it out. And what about the other end of this cable? That's the other end. That's one type of cable. That's useful if you're going to connect the function generator to the picoscope, so you can view the signal on the picoscope. We're going to do it in the second tutorial. It's not the only cable you're going to use. There is another cable also that is very helpful in your experiment. You're going to use it. That's one end of the cable, so you can plug it here to the function generator. And the other end has like, the normal clips that you are using to connect it to the circuit. You got two of them, one to the ground and one to the light, so we can connect the circuit. Okay, so these are the cable. What other thing? Well, this button's amplitude. If you are going to move it clockwise direction, you're increasing the amplitude. If you're going to move it or turn the knob to anti-clockwise direction, decreasing. But observe, it's in the normal position in, and that's in this position you get normal values. In some application with digital, then you have to pull it out. It will give you small range. But in our experiments, common experiments, we are not using the small values, so you have to keep it in the amplitude button. The second one here to the right, that's the offset. The offset DC. What's mean offset DC? Well, first of all, you have to keep it in if you don't want to have the DC offset. If you want to add DC offset to your signal, pull it out, and then you can move it to the right, to the left, to increase or decrease the value of the voltage of the DC offset. If you don't want the DC offset, keep it in. What does it mean, DC offset? Okay, look at the signal. That's square wave produced by this function generator. And the value here, the minimum value is -1, and the maximum value is +1. So it's symmetric square wave. As you see about the zero axis, means the positive value is equal to the negative value. We say in this situation that the DC offset is equal 0. Which is corresponding to this DC offset button is pushed in. Okay, if you want to if you want to add DC offset, let's say you want to add a 1.5 voltage DC. So if you are going to add 1 point voltage DC, if you add 1.5 to -1, what you'll get 0.5 positive. If you add 1.5 to 1, you get 2.5. So now your new waveform will be from 0.5 to 2.5. Okay, so that will be your new waveform from 0.5 to 2.5. I mean, yeah, it should be fixed to 2.5. Okay, so that's, I mean, your waveform, and that's the DC offset. So the DC offset, it's a DC voltage constant value added or subtracted from the wave signal that you produced. Is it useful? Yes, of course it's useful. How useful it is? Okay, let's say here, I mean, you got from -1 to 1. Let's say that you want to make a square wave, start from 0 up to 2. So what you'll do? So what you're going to do, you're going to add +1. You make DC offset equal to 1. So if you add 1 to -1, you get 0. If you add 1, you get 2. So that your waveform be above 0 axis, will be from 0 to 0 to 0 to. That's if you want to produce a positive square wave. So these are the important things I want you to know right now. And thank you for your attention. All right.